Our first question today is 2-7, day 2, solving equations in one variable, is a real popular one to mess up, okay, for the test itself. All right. I want to explain myself with it, but I also want to do it and show you how simple the question can really be, because I have a lot of people who do it and they're like, well, geez, you must do this, you must do that. So I think I want to talk about it this way. When you take the average of a test, okay, think about what you're doing. You take a score or a value you received or you have out of the total possible that's there, right? And you divide to find a percent score. That's what this problem boils down to. And I always have people freaking out a little bit with it because of that. But I give you kind of the stuff I want to do. If it just would just start working. There we go. The stuff I want to do right here. This, in a nutshell, is how I'm setting up the problem. Okay? I'm going to take the milliliters of pure acid. Okay? And I'm going to divide it by how many milliliters of mixture I have that pure acid is sitting in. And that division gives me my concentration percent of acid. Okay? Now you may have done this in chemistry, you may not have, and you don't need to. But what I'm going to do first is, from the first part of this problem through, this is my focus to set things up. Okay? So when I'm doing this, I'm going to calculate acid mixtures. How much pure acid must be added to 50 milliliters of 35% acid solution to produce a mixture that is 75%? Okay. Now, keep in mind what I just told you. I have a beaker. Let's do this. I have a visual. I have a beaker. Okay. It's not that Muppet, the Muppet beaker. You know that, little guy that helps the doctor. Oh, anyway, sorry. Beaker's a cute little Muppet. You can look him up. Okay. After this, I have a beaker. I have 50 milliliters of stuff in here, right? In this 50 milliliters, I have a 35% solution of acid. Now, how much pure acid is that? That's the thing I've got to find. So I'm going to start defining my units and everything as I'm going so you guys understand what's happening. The first thing I'm going to do is find my pure acid concentration, the amount of acid that is sitting in my 50 milliliters. So to bring it over, how much acid I'd have to add for it to be, 35%. Okay, so I find that at 35% concentration, okay, if I was going to say, well, how much acid's in there? It's like 17.5 milliliters of pure acid is inside this. So if I have distilled water, okay, and 17.5 milliliters of pure acid, I can add to that 17.5 milliliters of pure acid 32.5 milliliters of distilled water to get to my 50 milliliters that I have. Okay, but we don't have to know that. We just have to know how to get to our pure acid concentration. Okay. Now, as I'm looking at this, I have pure acid of 17.5. Well, 17.5 divided by my entire mixture, 50, gives me 35%. Okay, so that's where this idea of 35% comes from. Now I have a beaker of pure acid I'm going to add to my 50 milliliters. And how much of that pure acid do I put in there to increase it from 35% to 75%? Okay, so I want it to be 75% in the long run. So the things I'm about to set up as I go through, I want my X that I'm going to introduce in this problem to be milliliters of pure acid added. Okay, remember I'm going to add pure acid to my 35% mixture to increase it to 75%. So it has to be an incredible concentration of acid to bring it up from 35%. It has to be a higher concentration. In this case, it's pure acid. 100% of whatever I'm adding is acid. Okay. Now, when I think about this, I want to keep in mind that on top, remember, X is pure acid. Okay. So whatever X I add will add to 17.5 milliliters of pure acid, okay, will be the result. Okay, whatever X I add, X plus 17.5 is the pure acid in whatever mixture I have, okay? But also when I add X, okay, to my mixture, I'm also adding to the mixture. So my 50 milliliter mixture will also increase its volume by X, okay? So what I want you to think about when we're doing this, I have a so here, okay? So I've got X plus 50 is my milliliters of resulting mixture. So I want to make sure that it makes sense here, because I've got some folks when we go through this, there's a fast way to do it, but I want to make sure it makes sense before we start saying, okay, this is a little bit more streamlined way to do it. I have a concentration. Well, actually, here it is. This starts out with 50 milliliters, okay? It's right there, and I'm adding pure acid to it, okay? Now, this is a certain volume. As I add, the volume is going to increase from 50 milliliters. Whatever that volume is, it's X. So I'm going to go X plus 50 is my total concentration, my total mixture. But remember, the solution I'm adding is pure acid. When I first started, I wanted to find out how much pure acid I had. I found out it was 17.5 in the mixture that was 35%, of 50 milliliters. It was 17.5 milliliters of pure acid. Now, as I add more pure acid, my acid concentration will increase. How much? How much I'm adding? X. But I'm adding this X to the pure acid and, by the way, the total part of the mixture, okay? So that's why I'm putting this relationship together. And so when I'm doing this, I've got X plus 17.5 as my pure acid on top, okay? And then my total mixture is X plus 50, because whatever my pure acid is that I'm adding it to the total mixture volume, but it's pure acid. So I'm increasing the amount of pure acid by X as well, okay? Now, I have a relationship with this. I know that when I divide whatever the acid amount of volume is by the total volume of my mixture, I will have a percent of acid or concentration. And that is why I'm looking at 0.75, because I'm supposed to increase it to 75%. Okay? So it's completely thinking my test out of the total, my acid out of the total. Okay? And now I just solve this. I multiply both sides by X plus 50, and I multiply those by 0.75, and I'm solving from here to find out what the volume of pure acid is that I should add to the original 50 milliliters at 35% to increase it to 75% acid concentration. Okay? So as I solve, coming through, I find out that X is 80. Are you finding out that X makes 80? And does that make sense? Now, these acid questions as an Algebra 2 student are a mixed bag of success, okay? But I find as you understand what we're doing in the problem, it makes more sense. I'm just looking for a percent of acid out of the total mixture. And when I add an unknown volume of pure acid, to a percent, to amount of acid that's there, I'm also adding that unknown volume to the total mixture. And that's why we have this X on top and bottom, okay? And we're looking at percent at the end, and this is my 75% as I'm going through that. So now, it's a word problem, word answer. 80 milliliters of acid must be added to the 35% acid solution to make a 75% acid solution. Okay, and I've got some people that are going through, Bloom, you know, why would you do X? And I'm just trying to explain what I'm doing with the problem. I'm trying to be clear about what's X. How did I find this 17.5? 17.5 is the amount of pure acid that exists in that 50 milliliter solution, okay? And that solution was created from pure acid and distilled water. But you didn't have to know that. You just had to know that when we make the increase, we're adding pure acid to pure acid, and we're adding that pure acid to the total volume, and that's where I got my X plus 17.5 all over X plus 50. Okay? Is it making sense? Yes? No? Just really glad it's Friday. You don't have to hear Bloom drone on again. Okay. All right. So that's that problem. We're done, but we can check our graphing calculator to see what it is. And really, I'm just looking at this problem of X plus 17.5 over X. So my Y1 would equal X plus 17.5 all over X plus 50. My Y2 was 0.75. And I'd find out where they cross, what mixture I'd add to it. Okay, so I can double check it that way too. Now, part of today is not only doing the problem, but able to check your answer on your calculator. Okay, and there'll be the next one we're just going to do on the calculator. Okay, because it'll just be something to get done, and want to make sure we have an example of that. But always, as we go through these, if you can check it, do so, because your calculator work is just as important. Being able to figure out, because MCA, SAT, ACT allows those. Okay, they allow the calculator, so let's make sure we know how to use them. Going on to our next problem. We're finding a minimum perimeter. Okay, when we're finding a minimum perimeter, we're going to be looking at a graph that has its minimum down. Okay, if it's a minimum perimeter or a maximum perimeter, or we're going to maximize the perimeter with the amount of stuff there, but we're looking at a minimum perimeter here. Okay, find the dimensions of a rectangle with minimum perimeter if its area is 200 square meters. Now you got to think about perimeter as we're going through, and we got to think about area. And I want you to keep in mind as we're talking about this today that when they do this, hey, we have this and this, we got area, we got perimeter, we're thinking about relationships between the two, okay? And I'm going to set up a system of equations. We're going to substitute for a variable based on the information provided, okay? So when I'm doing this, I'm thinking, all right, I've got this rectangle. It's supposed to have an area is 200 square meters. Okay, so I've got a rectangle that has 200 square meters. And we know area is length times width, right? So I can have my one side be X. Okay, you okay with that? I need to define my other side in terms of X and area. Okay, instead of saying, hey, it's L, I'm going to use area and my X value to represent my length. If I'm saying X is W. So I'm really going to go and say 200 divided by X is my W. Are you okay with that relationship? I mean, if my area is 200, and X is one of my measurements, my other measurements must be 200 divided by that X. Okay? Now, when I'm setting that up, that's my thought. And why I set it up that way is that's the information that was provided to me in the problem. Okay? Now, I'm going to take that information and I'm going to plug it into my perimeter equation. Okay? And people are like, well, why the perimeter equation? Well, what am I supposed to minimize? My perimeter or my volume? I already got volume. My area, I already got area. So they gave me all this information about area to work with perimeter. So I'm defining my variables, I've got them going, and now I'm going to put them into my perimeter equation. So now I've got P is equal to 2 times, I've got L, my length, let's say that's 200 X, right? Plus X, 200 divided by X plus X. Are you okay with what I'm doing? I got my two variables. I have it, L and W. I've got it down to one variable, okay? So I have an easier time solving a system of equations. And really keep in mind, I had two variables. I had length and width, and I have two relationships, perimeter and area. And I use those relationships to help me solve for a missing variable, okay? Now, in this case, I'm going to take my graphing calculator now, and I'm going to put in this for Y1. Okay. Now, I think I'm going to put in a window. Bless you. I don't know what should my window be. It's I think I'm going to put in like a window of my Y is -10. Well, actually, my X will be first. -10 to 50. Let's see what that does. My X window, -10 to 50. By my Y window, -10. Well, it goes up to 200 for my perimeter. I want you to be able to see that. It's going to come across there. So let's go up to 200. What the heck? Okay, I think that's what I'm doing for my window. So I got my stuff in there, and I think I got my window set at -10 to 50 and -10 to 200. Okay, so that's all I'm doing. I did my work. Okay. They are asking me to find the dimensions of a rectangle with minimum perimeter if its area is 200 square meters. Find this least perimeter. Well, the least perimeter, if I graph, no, maybe if it lets me, is going to look like that. Okay, well, how can I find the least on that? Minima, right? So I'm going to go in, calculate. I'm going to hit second calc, if it lets me. And I'm going to go along my graph down to a minimum, or at least try to find it. Hit enter for my left. Oh gosh, whiz bangerangs. Let's try that again. I want to go minimum. I thought I hit 3, but I guess I didn't. So I got my left bound. So I hit enter. And now I'm going to go over my right bound. Maybe. Okay. Someplace on the right side as it starts going up. And when it stops, I'm going to hit my right bound. And I'm going to be able to take my guess. And I got my minimum of 56.568. Okay, or 56.569 at x equal 14.14. Okay, so I've got my minimum here. I think I got that right down here. Minimum 56.568 at x equal 14.14. Ladies, it's nice to see you both. You guys have a great day. The minimum perimeter would be 56.568 meters for the area of 200 meters squared. Okay. So what's the shape of the minimum perimeter? Yeah, okay. The shape of the minimum perimeter here is a square as we look through it the way we set it up. Okay, so keep that in mind as we're looking through what those shapes might be for minimums and maxima. Questions about what I did with my calculator? Questions about how I set up the problem at all? Are we okay? And again, as we go through, you guys saw the picture of the problem itself, about what that function looks like. Any other follow-ups? Okay, let's look at problem 7. Read 7. When we're looking at this with the Stewart Company, the Stewart Company, we've got going. The Stewart Cannery packages tomato juice in 2-liter cylindrical cans. Keep in mind, that's kind of a significant piece. And by the way, 2 liters is the same as 2,000 centimeters cubed. Okay, just a little FYI, because I'm going to use 2,000 or 2, and people are going to freak out a little bit, but they told me that. That's what this case is. Now, find the radius and height of the cans if the cans have a surface area of 1,000 centimeters squared. So now, I've got to be thinking about volume here and surface area. Now, I put these formulas in extra. This is one of those things, those times where recall from geometry is expected in these types of questions. I just put them in so I didn't have that be our struggle. I wanted our application to be our issue. Okay, so I've got volume and surface area. So I've got volume to deal with as I go through, and I've got surface area. But I'm looking at this, and I'm going to tell you why I answered the volume part as I did. I'm supposed to find the radius and height of the cans if the cans have a surface area of 1,000 centimeters squared. I'm going to have a bunch of information with the surface area. So I'm going to use my height to help me find radius. Okay, and I'm going to get radius in there because in my surface area formula I have h in there, and I'm going to take 2,000 over pi r squared and substitute it in. Now, some folks would be like, well, why didn't you choose to solve for something else and plug it in the other side? I could have. It's your choice to make it whichever way you want. Once you know the relationship, it's your choice to solve for a certain variable, and you can go the other way. You don't always have to go this direction. I just chose it because it was less messy, okay, to pull things out when I did it. So I'm going to plug in where I see h right here. But before I do that, I want to make sure that you recognize a couple things. Why did I say the volume was equal to 2,000? Because they said here that the tomato juice is 2-liter cylindrical cans. That's where the volume of 2,000 came from. Okay, so that's where that 2,000 came from. I'm choosing to leave my units in centimeters when I'm doing this, okay, versus liters or meters, I should say, when I do this. So know that my answer is going to be in centimeters, so I can easily talk about those measurements when I'm done. Now, as I put this back down, I'm putting that in there with h, and now I'm going to substitute as I go in. So I got 2 pi r squared plus 2 pi r times 2,000 pi r squared equal 1,000. So that's my relationship. I'm going to try to combine like terms and make it simpler to put in. Okay. One of the things I'm going to do right off the bat, this pi kind of knocks itself out, and I've got now r to the first power if I take care of that. But now I got that 2 times 2,000, so I'm going to have 4,000 up top on this next one. That's why I have 4,000 over r equal 1,000. Now, I'm going to use my calculator on this. Okay, I'm not going to have you try to factor it out or anything, because we have that as a tool, and that's one of the things we're doing today. Our objective today is to solve rational equations using substitution and the graphing calculator. Well, I've got substitution, now I'm going to use the graphing calculator. My setup on this is going to look like this. I'm going to put in my graphing calculator, and I'm going to blue this up for a second so you can see which functions which. This is y1. That's this form, that's this equation right here coming across. This goes in y2. That's this going across. Okay? I'm going to have two spots, two pieces of information where they cross. My x values, I'll have two. Well, I only have one variable left. Okay? That's r. So the values I'm actually finding are the r values of my container. And I have the height related in terms of r. So after I find that, I can find my heights as well. Okay, coming back to this. So once I determine what my r is, and one of them is 9.65, as I pop those in, and that's this, as I'm talking about my two size options. I've got two size options. And you got to keep in mind, companies will decide on a size option based on their choice. Maybe it's a packaging choice. Maybe they can get more containers in a certain size box, and then the box that they're putting the containers is cheaper than the bigger containers, and they can get less in there. Those are choices that the company makes, okay, as they go through and apply these things. This is my first one. That's 9.655. My other one is 4.619. That's this one here, 4.619. And this one on the right side is 9.655. When I go into my calculator and I find the intersections of those two functions, y1 and y2. Okay? Now, after I do that, I'm going to reread because, yeah, I got radiuses, but they're looking for find the radius and height of the cans. So when my radius is 4.619, I'm going to take my h, which equals 2,000, divide it by pi, 4.619 squared. Make sure when you do that, you got this completely inside parentheses. Otherwise, you might make an oopsie and divide by pi and then multiply by 4.619 squared. So what I'd like you to do is take your calculator out and practice. Okay, and some people think, Bloom, come on, it's a calculator. This is one of those duh moments I don't want you to screw up. Okay, so when you do this, you can either go 2,000 divided by pi and take that answer and divide that by 4.619 squared, or you can take them both inside of parentheses and do it together. Okay, but practice it, because I'm telling you, if you're going to make a mistake in this problem, it's right here on the h evaluation. Okay, and your h value should be 29.835 centimeters. Okay. Remember, they're 2.5 centimeters, 2.54 centimeters per inch. So that's like 15-inch. It's like a 15-inch can with that radius being 4.3 inches across. Pretty narrow can. Or the other one, if I put in 9 as I go through, I can do that. And I got those written down there, I guess. I didn't think I did that. We love the fat fingeritis days. Okay, we're going to put it down there. Stay. Okay, are you okay with my radius? Are you okay with my height? And how I did it, and how I decided that there were going to be two size options. Because my graph crossed in two places. It's a choice, right? We doing okay? Any other questions? Now, part of today is just working with, that's going through. So here's my size options. This is really my solution as I'm going through this thing. Two size options. These are my sizes. I got R and H, and that's what I'm doing with connecting them. I have quick review 2.7. I'm not going through those. I want you guys to practice them. Some of the things I'm noticing is that we're not finishing evaluation. We're not doing great with multiplying and knocking out the right stuff. So I would like you to spend the next 7 to 10 minutes, and just do those bottom 2, 4, 6, 8, 10 questions. Okay, and then we'll check answers between your row partner. If you have any discrepancies and you can't like discuss out, I'm more than happy to break the tie, okay, and see what's going on. But I need you to kind of be on the practice side of these things, okay, just to see where it's going. And then the remainder of today's time is to do the assignment. And that's right there. And by the way, we do put 51 on this one. If you did it yesterday, I'm okay. I apologize for putting it over, but I have 11 questions. And really, you're just doing the odds, so that makes it 7 questions with 51 added today. That's why you're doing the bottom of this and those 7 questions. You're going to do mixture questions. You're going to do something like the cannering question, and you're going to do another one. Geez, I forgot what the other question was like. That minimization of your perimeter. Okay, so keep those in mind as you go through. If you got questions, I'm more than happy to explain them. Know how to do each one. Be comfortable with them. If you have any questions, I'll do my best with explaining them again. Thank you for your time today, folks.